my dear student, I'm Mr. Kitwala from Educare TZ. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our discussion on the topic of wave for the subtopic of the wave motion, my dear students. So before we proceed with our discussion, we should remember where we ended on the last session. So on the last session, we tried to see how can we derive the formula of the displacement and also of the velocity when the particles undergo a simple harmonic motion. And we say that if we have the particles trying to move from right up to the from left up to the right, now their displacement must be equal to a sine bracket wt minus kx. This is what we demonstrated on the last session. Also, we said that if conversely, if the particles are starting moving from right up to the left, their displacement can be expressed as a sine bracket wt, then we plus by the kx. But if those particles are trying to move at the same time, they move at the left side, from the left side to the right side, then they turn back from the right up to the left side. So their displacement must be equals, to a sine bracket wt, then we plus or minus at the kx, my lovely students. This is how we express my lovely student here. And finally, for the displacement, for the velocity, we should take the formula of the displacement and derive it for the first, and apply first derivative. If we apply the first derivative, we should obtain that the velocity would be expressed as the a w cos bracket wt plus or minus at the kx, my dear students. This is what we should express. We should explain, my lovely students. So after there, we say that if is at the same, if the particles are the same, now we could express their velocity, which is equal to plus or minus, must be equals to plus or minus w divided by the k, and the k expressed at the wave a number, while the w represent the angular velocity. This is what we demonstrated on the last discussion. So for our today discussion here, we are going to look how can we solve some examples. How can we solve the examples related with the displacement and also the velocity here. As we see, we have the example number 3 for our topic number 8. And our example say that a wave travel along a string is described by this formula. We have the wave, and those wave they try to travel along they travel along a string. We have the wave, and that wave try to move along a string. They try to be described by y, comma y by y by y at the coordinate point x, comma t, which is equal to 3.3, then assign a bracket 2.7 t minus 72.1 x. This is our formula that we have been given, the equation of the displacement, which is expressed like this one. So in which y is in millimeter. Now this y here, the value of y is in millimeter, while this x is in meter. Kwa yule y yupo kwenye millimeter, while this x is in a meter, my lovely students. And t is in second. The t that we observe here is in second, my lovely students. So what is the amplitude? Roman 1, we are supposed to go and find the amplitude. But Roman 2, we have been asked to find the wavelengths. Kwa huyu Roman 1 tutafuta amplitude, lakini Roman 2 tutaweza kutafuta wavelengths, my dear student. While Roman 3, we are supposed to go and find the period. As we know that the period is equal to reciprocal, I think is equal to reciprocal of the frequency, or is equal to angular velocity is equal to 2 pi divided by the angular velocity. This is how we could obtain the P here. And Roman 4, we have been asked to go and find the frequency. How can we determine the frequency? Roman 5, the velocity of this wave. Velocity ya hizi wave itakuwa ni ngapi? This is what we have been asked on these questions. First of all, my dear student, here we should focus for our equation that we have, the equation of the displacement along to the coordinate point x, t, which is equal to 3.3 sine a bracket wt, we minus sine bracket 2.7 t minus this 72.1 x, as we seen here, my lovely students. How can we get Roman 1, the amplitude, Roman 2, the wavelength, Roman 3, the period, Roman 4, the frequency, and finally the velocity of this waves? So here we could solve this one. First of all, let us go and start with the amplitude. Here we should solve this equation by recalling the formula of the displacement when the particles are moving from the left and they are into the right side. Kwa tutarecall ile, alafu mwisho wa siku tutafanya comparison kama tunapoona formula yetu hii hapa. Kwa tutarudi kwenye ile equation ya I think is 8.10 pale. Ukiweka comparison utakuja kumuona kasi kwamba amplitude wetu ni sawasawa na 3 point na huyu, kwa sababu formula inasema y the displacement x, t might be equal to a, the a sign. Therefore, if we make comparison, we should obtain the amplitude is equal to 3.3. While the wave number, we have been asked to go and find the wave number here. The wavelength, I think it is not the wavelength, it is the wavelength. But before we find the wavelength, we should understood the wave numbers. Kwa tutarudi tena pia kwamba tumpate yule wavelength ambao tumeulizwa kwenye Roman 2, lazima tuanze kwanza na wave number. Kwa ukimeki comparison kutumia ile formula yetu ambayo tulitengeneza kwenye ambayo ni equation number 10 for our topic number 8, we should obtain first of that the kx, because our formula said that the displacement along to the x, t is equal to the amplitude sine wt minus the kx. Now k might be equal to 72.1. Kwa hiyo k atakuwa ni sasa na 72.1 as we have been told, my lovely student. Now this k, this wave number which is represented by the symbol k might be equals to 72.1. Now let us take this k and finally try to equate the formula of k. K is equal to 2 pi divided by the wavelength. But on our equation here, we should identify the wavelength. Kwa wavelength itakuwa na uwezo wako, utaweka over 1 alafu ta cross multiplication, utajikuta kwa